Hi everyone, this video is going to take us through the basics of multiplying polynomials. We won't finish this entire set of Cornell notes in this video, but there will be a part 2 that you can watch if you miss it in class. First thing I want to just remind you about is the product property of exponents, and that's when we multiply powers with the same base, we always add their exponents together. So for example, I have here 4x squared times 2x cubed. Okay, so if you think back to what we did last year, we can multiply those coefficients together. We can multiply the 4 and the 2 together and get 8. And then when we multiply the x terms together, all we need to remember is to add those exponents. So this would be to the power of 5, because 2 plus 3 is 5. Okay, the same concept applies right here. We have k squared times m to the third power times 2km. Okay, one thing to remember is that in front of this first term, it's really a 1 there. We don't usually write the 1, but it's there. Okay, so we multiply our 1 times 2, that gives us 2. We multiply our k terms, k squared and k to what is really the first power. So we add that gives us k to the third. And then m cubed times m to the first gives us m to the fourth. Okay, so let's look at how do we multiply a monomial by a polynomial. And a monomial is just a one-term expression. So here I have 2x times the quantity of 5x squared plus x minus 6. Well, we're just going to apply the distributive property here. I'm going to take this 2x and multiply it by everything inside the parentheses. Okay, so 2x times 5x squared gives me 10x to the third power. 2 times 5 is 10, and x times x squared is x to the third power. And then 2x times x, well, that's just 2x squared. And then 2x times a negative 6 gives me a negative 12x. And all I'm really doing here is applying this product property of exponents, where I'm adding the exponents on those x terms and multiplying the coefficients together. Okay, let me try one more with you. Let's look at b right underneath it. We have 4a squared b cubed times the quantity of 2a cubed b minus 3ab squared. Okay, it seems like a lot, but just take the rule of adding the exponents together when we have the same base. So we'll start by multiplying this outside term by our first term on the inside. So we multiply those coefficients together. 4 times 2 is 8. Okay, now look at the a squared terms. We've got a squared times an a cubed. Add those exponents. A to the fifth. And then we've got b cubed times that 1b to the first power. Add the exponents. B to the fourth. Okay, that's simple. Okay, we'll do the same thing, and I'll do it in a different color so you can see it better. We're going to multiply this first term on the outside by our last term here. So we'll multiply the coefficient. 4 times, it's really a negative 3, negative 12. Our a squared term times an a to the first power. So a to the third, I'm just adding the 2 plus 1. And then b cubed times the b squared. So b to the fifth power. Okay, so really all you need to take into account is that product property of exponents. Okay, I want you to try C on your own and see what you come up with. All right, finally for this video, I want to talk about multiplying two polynomials together. Two binomials specifically. And binomial is just a two-term polynomial. So one thing that I suggest is the box method. When we start throwing in extra terms, it gets a little bit messy, but the box method might help us keep our work a little cleaner. So one thing I like to do is I have 2 terms times 2 terms, so I'm just going to draw a 2 by 2 box. Just like this. And on the outside here, I've got my first expression, which is x minus 6, So I'll write an x and a negative 6 there. And my second term is x plus 1, or second expression, I should say, x and a 1. Okay, so I'm going to use this box method to multiply my terms together. So in this upper left-hand corner, we've got x times x, which is x squared. Moving to the right, I have x times 1, which is just 1x, or x. Moving to this bottom left, I've got negative 6 times x, just negative 6x. And then negative 6 times 1 in my final box, negative 6. And all I have to do here is combine my like terms. Okay, so I'm left with, let's write it off to the side. I should have left a little bit more room. But we've got the x squared. We've got a negative 6x plus x, and then the minus 6. Okay, we don't want to leave it here. Like I said, we want to combine those like terms. So we'll leave this as x squared. Negative 6 plus 1 is negative 5, so negative 5x minus 6. And there is our final answer. Okay, I'll show you one last example, and I'm going to leave C for you to do on your own. All right, so we've got two binomials. I'm going to draw a box. Draw it over here. Actually, no, I'll draw it a little bit over here. So I've got a little bit more room to write that polynomial this time. Two by two box. My first expression is 2w plus 3. And then my second one is w plus 4. So no negatives to deal with this time. That's always good. Okay, so starting in the upper left-hand corner, 2w times w. Well, that's just 2w squared. Moving to the right, 2w times 4 gives me 8w. I'm just multiplying 4 times 2 and keeping the w. Bottom left, we've got 3 times w, which is 3w. And the last square, we've got 3 times 4, which is 12. Okay, let's list these terms out. 2w squared plus 8w plus 3w plus 12. Combine your like terms, so we're left with 2w squared plus 11w plus 12. So you're going to try example C on both of these top examples here. We'll go over them in class and see how you did.